All right, factoring polynomials homework. Let's get it. Number 1, 30b cubed minus 54b squared. So I want to take out the GCF, numbers and variables. So they're both even. Actually, I could take out a 6. So this is going to be, so if I take out a 6, what's left behind? 5 and minus 9. I'm going to take out a b squared also, right? Because there's a b squared common to both. So 5b is left behind, minus 9. So we took out the GCF, right? So 30 is divisible by 6. 54 is divisible by 6. So when you factor out a 6, 5 and 9 are left behind, right? Negative 9. And then you look at the variable, it's like, okay, this has 2 b's, right? B squared. And this has 3 b's. So we're pulling out a b squared. All right, number 2. GCF. Z is common to both, or to all three, right? It's a trinomial. So Z is common to everything. So I'm going to take out a Z. Again, I strike my Z's because my Z's look like 2's. What's left behind? Z squared minus 6Z minus 72. Okay. We have a quadratic. I want to come up with 2 numbers that multiply to make negative 72, but add up to negative 6. So it's best to just start with the factors of 72. All right, we can do 1 and 72, 2 and 36. Six is going to be 6 and 12. Okay, so I can definitely make a 6 come out of 6 and 12. So negative 72, right? So that means one of them has to be negative. But which one? Well, that's when you look at the term, the middle term, and because it's negative, the big one. So positive 6 and negative 12. Those are our numbers. So we're going to put this into our factors. Is going to be plus 6 minus 12, and Z is our variable. And then don't forget about the GCF outside, right? Z is part of it also. All right, number 3, 54m to the 5th plus 18m 4th plus 9m cubed. 9 can come out of everything, right? Everything's divisible by 9. So if I take out a 9, I can also take out an m cubed, right? M cubed. So what's left behind? 6 m. Subtract the exponents. So it's going to be m squared plus 2m plus 1. Okay. We got to factor the quadratic. So here, the a term is not 1. Right? The a term is not 1. So there is a particular method. We can either do some slide and divide or factor by grouping. Those really are only 2 methods. But since we're factoring polynomials, right, let's stick with factor by grouping. It'll give us a good practice. All right, so what we're going to do, so if this is my a term and this is my c term, right, this is the AC method. So we want to multiply a times c. And the last one, we didn't really have to do this because a was 1. But here, a is not 1. And technically c is 1. But regardless, a times c is what has to happen. right? So 6 times 1 is 6. So two numbers that multiply to make 6 that add up to 2. So we look at our factors. 1 and 6, 2 and 3, and that's it, right? Once you hit two numbers that are consecutive, there aren't any more factors. So can any of these make 2? Nope, it cannot. So what does that mean? That this is it. This is the answer. We're done. It is as factored as it can get. You always want to check to see if you can factor it further. So okay, number 4. 3y to the 5th minus 48y cubed. Is 48 divisible by 3 is a question. Yeah, it is. 3 goes into 4 once, then 3 goes in 18 6 times. So I can definitely take out a 3. I can also take out a y cubed. So y squared minus, what do we say, 18? Okay. Y squared minus 18. We look to see if this is, it's not 18. It's not 18. 16. Y minus 16. Okay, we look to y squared minus 16 to see if this can be factored any further. The difference of squares, right? You always got to be on the lookout for perfect squares, right? 16 is equal to 4 squared. So y squared minus 4 squared, that's a difference of squares. Right, we're using the fact that a squared minus b squared can be rewritten as a minus b, a plus b. So a is y, b is 4. So this is going to be 3y cubed y minus 4 y plus 4. All right, number 5, x cubed plus 8. No GCF, but 8 is a perfect cube. So the 8 is really 2 cubed. And again, we have a situation where we can apply one of our formulas. So this is a sum of cubes. So a sum of cubes is plus minus plus. That's the pattern that I teach. And we're going to have a plus b, and then a squared minus ab minus b squared. Right, the whole plus minus plus is, so plus minus plus. Yeah, plus minus plus. Okay, so a is x, b is 2. So put it all together. X plus 2, x squared minus 2x plus 4, right? Because 2 squared. All right, number 6, 27m cubed plus 1. No GCF, but 27 is really 3 cubed. So this means 3 cubed, m cubed, plus 1. And we could really say 1 cubed, right? Because 1 cubed is 1. Okay, the cube that's on the 3 and the m can, in a sense, be factored out. Plus 1 Okay, we have a sum of cubes again. So this is going to be our A. 1 is going to be our B. And this is a sum, right? So plus, minus, plus. Let's try to get it right on the first try. So we got 3m plus 1, a squared. So 3m squared. So 3 squared is 9. M squared minus a times b. That's nice. 3m plus b squared, which is 1. Okay. We look to see if the trinomial can be factored any further. So multiples of 9, factors of 9 that add up to 3. 1 and 9, 3 and 3. All right, it cannot. So this is as far as it can go. Number 7. Okay, 27a cubed. This is very similar to our previous problem. It's a 3 cubed, a cubed minus 1,000, which is 10 cubed. Right, 10 times 10 times 10. So we have 3a cubed minus 10 cubed. So 3a is our a basically, and 10 is our b. So now we have a difference of cubes, right? A difference of cubes, because it's subtraction. So the pattern is net minus, plus, plus. So keeping the same shape as earlier, a minus b. So 3a minus 10, and then plus, plus. So we got a squared, 9a squared plus a times b, 30a plus b squared, which is going to be 100. Okay. Safe to say, I don't think the second part's factorable. Let's go with that. 900. I don't think it's possible. Number 8. 192. W cubed minus 3. I feel like 192 is divisible by 3. It is, right? Because 3 goes into 19 6 times. 1 left over. 3 goes into 12 4 times. And so what's left behind? Well, actually, since we're taking a 3 out, 64 is what's left behind. W cubed minus 3. Okay. Let's see. All right. So 64 is 4 cubed. Right? 4 cubed. 4 times 4 is 16 times 4 is 64. W cubed minus 3. Okay. It would be really nice if somehow the 3 had a cube on it. Let's think about this. Is this even possible? Is it even possible? All right, so this is going to be 4w cubed minus 3. Oh, man. It's not 3. It's 1. Okay, that makes life so much better. All right, so that means this is A, this is B, and it's a difference of squares, a difference of cubes. So a difference of cubes because it's subtraction. So this is going to be minus plus plus. So 3a, which is 4w, minus 1, a squared, so 16w squared, a times b, so plus 4w, plus 1 squared, which is 1. Okay, and 16. Nope, not factorable. 1 and 16, 2 and 8, 4 and 4. Right, none of those make 4. Okay, number 9. So we have 4 terms. So this is going to be factor by grouping. So you always want to split it right down the middle in front of the symbol. So we're looking at the left 2 terms. So x squared can be taken out. And left behind x plus 1. All right, right hand side. We already have x plus 1, right? So we want to factor something out so that x plus 1 is left behind in the parentheses. Well, x plus 1 is already up here on the right, so we're going to factor out a 1. You can take out a 1, a positive 1. So this means that x plus 1, so that's one of our factors. So x plus 1. And the leftover pieces, those are the other factor, x squared plus 1. And x squared cannot be factored anymore. Right? There's no such thing as a sum of squares. It doesn't work out. Okay, number 10. All right, split it like we know how. Left 2 terms. Y squared is the only thing I can take out. Left behind is y minus 7. Okay. So I see y minus 7. Dare I say to go ahead and just put y minus 7? Sure, we know it needs to happen. Well, let's see if it actually can happen. Right? If we try to factor some numbers out and we can't get it to work, then we know that it's not factorable. So here 4 and 28, so 4, positive 4 can be taken out. And we check ourselves, right? 4 times y, 4y. 4 times negative 7, negative 28. So we know we're good. Y minus 7. So y minus 7 is a factor. The leftover pieces, y squared plus 4. This is going to be y squared plus 4. And nothing further can happen. Okay, number 11. Split left-hand side n squared. Inside is going to be n plus 5. Right-hand side, I know that n plus 5 needs to show up. That's the only way that this works out. But let's see. So here this is negative. So I'm definitely factoring out a negative. Right, if that term is negative, you gotta pull out a negative. So we're gonna take out a negative 9. And we check ourselves. Negative 9 times n. Negative 9n. Negative 9 times 5 is negative 45. Okay. So n plus 5. And the leftover pieces, n minus 9. N squared minus 9. Okay. Can n squared minus 9 be factored further? Yeah, it can, because it's a difference of squares. 9 is really 3 squared. So that means our a is going to be n and our b is going to be 3. So we have n plus 5 and then n plus 3, n minus 3. All right, number 12. Split it down the middle. Okay, left-hand side, we got a couple things that can come out. So now a coefficient can, right, 25 can go into 100 4 times. If I take out a 25, I can also take out an s squared. So what's left behind? An s and minus 4. So let's do that in a different color. S minus 4. All right, right-hand side. S minus 4. Okay, because this is negative, definitely going to take out a negative. So negative 1. Right, because S and 4, there's nothing that can come out. Okay. S minus 4. And then the leftover pieces. So 25 s squared minus 1. 25 s squared minus 1. 25s squared is a perfect square, right? 25 is really 5 squared. So this means 5s minus 1s. So this is our A. This is our B. Put it all together. We have s minus 4. 5s minus 1. 5s plus 1. All right, so s's and 5s kind of clash there, but there are s's. I guess that's a way of doing it. So they don't look like 5s. Okay. We're moving right along. Okay, number 13. X to the 4th minus 25. What am I thinking? I'm thinking that 25 is really 5 squared. And I want a difference of squares, right? That's what's jumping out at me, is that I have two things. Can this be a difference of squares? And actually it can, because x squared is x to the 4th, right? We're using the exponent property that when you take a power to a power, raise a power to a power, you multiply. So x squared minus 5 squared. So x squared is our A, 5 is our B. So this is going to be x squared minus 5, x squared plus 5. Okay, x squared minus 5. 5 is not a perfect square. I mean, yeah, it cannot factor out cleanly, so without introducing a square root, and we don't want to do that. We don't want that. All right, number 14. Okay, so here we have a trinomial. Now, wouldn't it be nice if this was squared and this was just not here? Right, if that's the case, right, anytime we have this situation, right, where we have an exponent, leading exponent, right, the leading term, and then this is half of it, right, 4 and 2. Or, ideal situation would be 2 and 1, right? A squared plus 7a plus 6, right? But in this case, it's going to be a to the fourth, 7a squared. So this could be a to the sixth plus 7a cubed, right? Anytime this is half, then we're going to treat this like a quadratic, right? We're going to treat this like a quadratic. Treat like a quadratic. And it's going to factor. So two numbers that multiply to make 6 that add up to 7. So that's 6 and 1. They're both positive. Okay, and normally we would just put the variable. But this is where we got to stop and think for a moment. All right, if we were to FOIL this thing out, right, distribute, a times a would be a squared. Well, we want a to the fourth. So whatever this middle term is, right, a squared, that's basically what we're going to use. Because now, when we distribute this out, a squared times a squared, you add the exponent. So 2 plus 2 is 4. And they're not a perfect square, so, or a difference of squares, so that's all we can do. Okay, same idea. Same idea. So just treat it like a quadratic. So I'm going to multiply, right, this is a and this is c. This is going to be negative 72. Two numbers that multiply to make negative 72 that add up to negative 1. Okay, so I know from my times tables that 72 is 8 times 9. 8 and 9. But one's negative. And because I want them to add up to a negative, the big one has to be negative. So 8 and negative 9. So what does that mean? That means that, so I could factor this. This is here. Look, I'll do it two ways. I'll give you an example. So this is gonna be plus 8 minus 9. All right, and then we have s squared, right? That's gonna be our variable. However, because we multiplied a times c, we have to account for that, and we have to divide that 3 back out. Okay, so this is where math gets a little tricky, right? You just had to have seen this before to know. But if it can be divided evenly, right? 9 divided by 3 is 3. Well, then that's what it is, right? S squared minus 3. But on the left, right, 8 divided by 3, it's not a clean number. Like, it's not a clean break. So what's going to have to happen is we're going to have to move this number up. Right? Because essentially what's happening is if I multiply this thing by 3 to clear the fraction, right, the 3 is going to go here, and the 3 underneath the 8 is going to disappear. So I'm essentially just moving it up. That's what we teach. So, or it's what I teach. So this is going to be 3 s squared plus 8. Okay, now let's say you're like, hey, yo, wait a minute. I don't like that. That's not cool at all. Okay, I got you. Check it out. The other way is that we write the first term, we write the last term, and we write the middle term broken up into our two numbers that we figured out. So this is going to be plus 8 s squared minus 9 s squared. And that makes sense because 8 minus 9 is negative 1. And then if we split this down the middle, factor out the GCF, so s squared, we have left behind 3s squared plus 8. Okay, I need 3s squared plus 8 to show up on the right, which it will. So this is going to be 3s squared plus 8. What are we factoring out? Because this is negative, we're factoring out a negative 9. Actually, I don't want to take out a negative 9. Let's take out a negative 3. Right, let's take out a negative 3. Right, because if I take out a 9, then we won't have 3s squared left in the right. So if I take out a 3, right, negative 3 times 3 is 9. Negative 3 times 8 is negative 24. So had we taken out a 9, and we couldn't even take out a 9 because 9 don't even go into 24. So haha. All right. So those match. We good. So this is going to be 3s squared plus 8. And then the leftover pieces, the outside parts, s squared minus 3. All right, number 16. GCF, m squared. Where I'm going to take out an m squared. What's left behind? 36 m to the 4th plus 12 m squared plus 1. Okay. So m4, m squared, I'm going to treat this like a quadratic, right? This is a quadratic situation. However, 36 times 1 is 36. So two numbers that multiply to make 36 that add up to 12. Okay. That's that. Is it though? Is it? That's the question. Something doesn't feel right about this one. Let me think for a moment. Damn, the 36 and 12. That's just it's like it feels sus, bro. It feels sus. Right, because 36, think about this for a moment. 36 is really 6 squared. And this is going to be m squared. Can I pull a square out? That's the question. No, because if I take a square out, that square is going to have to apply to the other one. Okay, this is going to be, I'll do some math trickery. So 6 m squared squared. Plus can't square anything to make 12. 1 squared. So I feel like, all right, so let me just think for a moment. 6m squared, right? Because this is my a. Plus b squared. If we square this, this is going to be 36 m to the 4th, right? Because this times this times this is going to be 1. And then 2 times this times this. 2 or 12 m squared plus 1. So what this means, so the question is, how would you know how to do this, right? It's an excellent question. So it's going to be m squared 6m squared plus 1 squared. That's the this is the factored form. Right? So there's really, so here this is going to be, right, 2 times a times b. And b is just 1. Right? Kind of just have to see it. Okay, number 17. 16x cubed minus 44x squared minus 42x. So x is common to everything. And they're all even. So I could definitely take out a 2. Can't take out a 4. 4 don't go into 42 evenly because these two numbers are so close together. So definitely taking out a 2. 2x, actually. So 8x squared minus 22x minus 21. Okay. 21 times 8. 21 times 8. 168. 168. I feel like this list is going to get long. So two numbers that multiply to make 168, right? Because I'm multiplying 8 times negative 21. So it's got to be negative. So let's see. 2 and what? 84. 3. 4 and 42. 6 is going to be twice. 28. Okay, that's it right there. So this is going to be, it's negative. So one of them has to be negative because the 22 is negative. It's going to go on the big one. So this means that 8x squared plus 6x minus 28x minus 21. Right, we split up this negative 22 in a very specific manner. Okay, split it down the middle. Factoring the GCF on the left, we have 2x. And what's left behind? We have what? 4x plus 3. Where we check ourselves, we try to put it back in. This is 8x squared, yep. And then 6x, so we're good. All right, right-hand side, we know we want 4x plus 3. We know it. And now we see if we can make it happen. So it's negative. Right, so I'm definitely taking out a negative. Negative what, though? I need 28. 4 times what equals 28? A 7? All right, so 7 times 4 is 28. 7 times 3 is 21. And we took out a negative, so we're good. So this is going to be 4x plus 3. And then the outside part's 2x minus 7. Okay. And then don't forget about the original GCF. 2x. 2x. Okay. I'm treated like a quadratic. So negative 60. Things that multiply that add up to negative 4. So 2 and 30. 3, 20, right? 2, 4, 6. 4, 15. 5 and 12. Getting close. 6 and 10. All right, I can make a 4 with 6 and 10. So since 60 is negative, one of them has to be negative. Because this guy is negative, that means the big one. The big one's going to get it. Okay. So into the fourth. Plus 6n squared minus 10n squared minus 60. So again, negative 4 can be created by positive 6 and negative 10. Split it down the middle. On the right-hand side, n squared inside we have n squared plus 6. On the right hand side, n squared plus 6 has to show up. Now let's see if we can. So because this is negative, I'm going to take out a negative. Negative 10. When we try to check ourselves, right, negative 10, yep, we're good. Negative 10 times 6, negative 60. So what this means, the factors, n squared plus 6, and the outside pieces, n squared minus 10. Can we look to see, can either of these be factored even more? No, it cannot. Cannot. All right, 19. Okay, we have a negative in the front. So I definitely want to take a negative out. Definitely want to take a negative out. This 4 goes into 500. So 125. So if I take out a 4 and I take out a b, what's left behind? We have b cubed plus 125. 4 times 125 is 500. Okay. We have b cubed. So can we make 125 into a cube? So 5 cubed. That's 125. Okay, so that means this is a sum of cubes, right? Where my a is b and my b is 5. All right, so in situations like this, when a is b, or b is a rather, I know it gets kind of confusing, but you got to be able to keep these things straight. So this is going to be plus minus plus is the pattern. So negative 4, b, a plus b. So a in this case is b. B in this case is going to be 5. So plus 5. All right, a squared. That means b squared. Minus a times b. So b times 5. So 5b. And then b squared, 25. Okay, two numbers that make 25 that add up to 5. 1 and 25, 5 and 5. Nothing else makes 25. So we're good there. Okay, number 20. 18c4 plus 57c cubed minus 10c squared. All right, 57 is messing this up. Otherwise, we could pull out a 2. But we can pull out a c squared. So 18c squared plus 57c minus 10. Okay, 180, right? 18 times 10. This is negative 180. And we want to make 157. So off the top of my head, 60 and 3, right? That one jumped out at me. 60 and 3 make 180, and 60 and 3 can potentially make a 57. How? Because one of these needs to be negative. But which one? Well, because this is a positive, that means a smaller one, right? This operation tells you what the big number needs to be, right? Because it's positive, then the big number here must be positive. Right? This always tells you the symbol of the bigger number. So let's go c squared. Right, it's along for the ride. 18c squared plus 60c minus 3c minus 10. Right, negative, or this 57 business got split up 60 minus 3. Okay, speaking of splitting things up, let's split it down the middle. So this is going to be left-hand side. 6c is what I want to take out. Right, if I take out a 6 and a c, we're left with 3c plus 10. 3c plus 10. Right-hand side, I know I want 3c plus 10. All right, we look and see if we can make it happen. And sure enough, 3 and 10 are here. So that means this is negative. We're going to take out a negative 1. Right, if you can't take out anything, take out a 1. So 3c. So we can't forget about the c squared. So c squared is definitely in our answer. 3c plus 10. And then the outside parts, 6c minus 1. 6c minus 1. All right, 21. Binomial. So GCF first. 4? Yeah, 4. About 8. No, 8 don't go in the 108. So we're going to take out 4. So this is going to be 4, and we're going to take out x squared. So what's left behind? 8 x cubed minus, so 4 goes into 10 twice, then 28 would be 7. Oh, that's nice. That's nice because the x is cubed. You can kind of see where this is going. Right, 8 is really 2 cubed. 27 is really 3 cubed. So what does this mean? That 2x cubed minus 3 cubed, and then 4x is out front. 4x squared. Okay, this is my a. This is my b. And this is a difference of cubes. So difference of cubes is minus, plus, plus, right? A difference comes first. So a difference, which implies subtraction, the minus sign comes first. The minus sign comes first. Okay. So we have, put it all together, 4x squared, a minus b, 2x minus 3, a squared, 4x squared, plus a times b, so 6x plus b squared, which is 9. So again, note, minus, plus, plus. Okay, checking the trinomial, 4 times 6, 36. I want things to add up to 6. 2 and 18, nope. 3 and 12, didn't add up to 6 though. Okay, yeah, that's good. All right, 22. Split it down the middle, without hesitation. Left-hand side, the left 2, z to the 4th. What's left behind? Z minus 3. Okay. Z minus 3, that's what we need to show up on the right. Z minus 3. Okay, this is negative. So I'm going to definitely take out a negative. And take out a 16. Okay, 16 times z, 16z. Negative 16 times negative 3 is positive 48. So z minus 3. That's a factor. The outside pieces, z to the 4th minus 16. Okay, now we ask ourselves, can this be factored in any further? Well, it's a power of 4. For this to work out, I would need 16 to turn into a power of 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So that means that 16 is equal to 2 to the 4th power. Which means this can be broken up. So z squared minus 2 squared. Right, I want to create a difference of squares situation, right? The difference, right? This is negative, and then we need this to be squared and that to be squared. And we're using exponent properties to do that. So z squared is a, 2 squared, which is 4, is b, and this is just the difference of squares. So this is going to be z minus 3, a minus b, a plus b. So z minus z squared, right, minus 4, z squared plus 4. Okay, we always got to check to see, can we go further? Well, yes, we can, in fact. So this middle term is the difference of squares also. So 4 is really 2 squared. So this means z minus 2, z plus 2. So these are our 4 factors, right? Z squared plus 4, it's not a thing. It can't be factored. Okay, solving equations, find the real number solutions of the equation. So we want the real number solutions. That means that's implying that we don't want complex numbers. We don't want complex numbers. So even though it's equal to 0, we're still going to factor this like we've been doing. So GCF is a binomial. So I'm going to take out a y squared. What's left behind? Y minus 5 is equal to 0. So two things being multiplied that equal 0. So y squared is equal to 0. Y minus 5 is equal to 0. So we're going to get, right, square root of 0 is 0. So y is equal to 0. We're adding 5. Y is equal to 5. Okay. All right, I'm going to move everything to one side. So this is going to be minus equals 0, right? Because we subtracted 50s. So on the left-hand side, the GCF, I can definitely take out a 2. 3, 4, 5, 6. Yeah, taking out a 2. And an S. So 2s. What's left behind? 9 s squared minus 25 is equal to 0. Check ourselves real quick. 2 times 9 is 18. 2 times negative 25 is negative 50. So we good. All right. Setting them each equal to 0. Right? 2s is equal to 0. 9s squared is equal, or 9s squared minus 25 is equal to 0. So left-hand side, s is going to equal 0. Right-hand side, add 25. So 9s is equal to 25. Divide both sides by 9. So s is equal to 25 ninths. Oh, but it's squared. So then take a square root of both sides. Take a square root of both sides. So s is going to equal square root of the top, square root of the bottom. So square root of 25 is 5. Square root of 9 is 3. And this is plus or minus. Right? Anytime you bring a square root, it's got to be plus or minus. So we have 3 answers. 0, positive 5/3, and negative 5/3. Okay. 25. This is what we've been practicing for, number 25. So it's equal to 0. We're going to split this down the middle. Left-hand side, I'm taking out a g squared. Left behind is going to be g plus 3. On the right-hand side, I know I want the same thing. G plus 3. Okay, let's look and see. So this is negative, so I'm definitely taking out a negative. And I'm taking out a negative 1. Because it's already g and 3. Like, there's nothing else I can do. So we're taking out a 1. Negative 1. So our factors, g plus 3. Leftover pieces, g squared minus 1. G squared minus 1. Okay, can this be factored? We're always looking for a difference of squares, difference of cubes. So in this case, in difference of squares, this is going to be your a, g, and 1 is going to be your b. So let's put it together. G plus 3, g minus 1, g plus 1. It's all equal to 0. It's all equal to 0. So I got to set each of these equal to 0. Or, if you're nice, you could just say, okay, g is equal to negative 3, g is equal to 1, g is equal to negative 1, right? It's always the opposite symbol, the opposite operation. These are our 3 solutions. Okay, 26. I'm definitely taking out a 4. Definitely taking out a 4. So 4, w to the 4th, plus 10 w squared minus 11 equals 0. So can we factor the trinomial? Well, yes, because we're going to treat it like a quadratic. What 2 things multiply to make 11 that add up to 10, right? Negative 11 and 10. It's going to be 10 and 1. That's not correct. It's going to be 11 and 1. Which one gets the negative sign? Well, we look here. Since that's positive, that means the big number is going to be positive. So the smaller one will get the negative sign. Okay. W to the 4th plus 11 w squared minus 1w squared minus 11. Right, and this 10 got broken up in a very specific way. So then when we split this down the middle, on the left-hand side, we're factoring out a w squared only. And what's left behind? W squared plus 11. So I know on the right, in parentheses, we're going to want the same thing. W squared plus 11. So we look and see that, okay, this symbol here is negative. So I'm going to factor out a negative and a 1. So we have w squared plus 11, right? That's the inside parts. And the outside parts, w squared minus 1. W squared minus 1. And this is the difference of squares, right? 1 is always written as 1 squared, or can be thought of as 1 squared. So that's our b. And then our our a is w. So this means, put it all together, w squared plus 11. A minus b, a plus b. So w minus 1, w plus 1. This is equal to 0. So we have to set each of them equal to 0. So this is going to be w squared plus 11 is equal to 0. When you subtract 11, right, we're going to get w squared is equal to negative 11. And when you take the square root of both sides, we have a negative inside the square root. We don't want this one, right? This is a non-real answer. So we don't care about that one. However, we do care about w equaling 1 and w equaling -1. So we only have two solutions for this one. That solution are the non-real solutions, which we'll cover in a later video. Okay, 27. I'm going to add 36 to both sides. And this is equal to 0. We're going to split it down the middle. On the left-hand side, GCF is going to be 5b squared, it looks like. What's left behind? A b plus 3. We check ourselves, right? B cubed, 15b squared, so we good. On the right, I know I want b plus 3 to show up. Let's see if we can make it happen. Okay, so this is positive, so I'm not taking out a negative, I'm taking out a positive. Positive what? Positive 12. And this is true. B times 12 is 12b. 12 times 3 is 36, positive. Okay, collecting the inside parts. B plus 3 is a factor. The other parts, 5b squared plus 12. Okay, equals 0. Right, equals 0. When we're solving, it's always equal to 0. So b plus 3, that's easy. B is equal to -3. 5b squared, however, plus 12. I don't like this at all. Because when we set this equal to 0, I can already see what's happening. I'm going to have to subtract 12. And look, we have 5b squared is equal to -12. And when we take the square root, we have a square root inside. So that one's no good. It makes a complex number. Yeah, we'll leave it at that. Okay. Number 28. I'm going to subtract 27p cubed from both sides. It's going to equal 0. So I'm going to take out a 3 p cubed. So this is going to be 16 p squared minus 9 is equal to 0. Right, so 3 times 9 and then p cubed. Okay, so we set each of these equal to 0. So right here, could we factor the right side more? Yeah, we could. But since we're solving for p and it's a square root, right, the power of 2, we're going to take a square root. I'm going to get the other answer anyway. So I'm not even going to factor this anymore. So 3p cubed is equal to 0. P must be 0. 16p squared minus 9 is equal to 0. Add 9. 16p squared is equal to 9. Divide by 16. So we have to take a square root of both sides. So p is equal to plus or minus. Okay, square root of the top, square root of the bottom. Square root of 9 is 3. Square root of 16 is 4. So our three answers are 0, positive 3/4, and negative 3/4. Okay, a little bit more funner problems here. So volume is 40. We need to find possible values of x. So I know volume is length times width times height. Length times width times height. So here's my length, here's my width, here's my height. So 2x times x minus 1 times x minus 4. And this equals 40, right? Should equal 40. We need some values of x. Okay, let's expand all this out, right? So this is going to be x squared, negative 4x, negative x, positive 16. right? And all that's going to get multiplied by 2x. Still equal to 40. So we actually can turn this into negative 5x. Okay. When we run the negative or the 2x through, it's going to be 2x squared. No, x cubed. 2 times negative 5 is negative 10x squared. And then 2x times 16 will be plus 32x equals 40. But I'm going to subtract the 40 from both sides right now. Minus 40, which is equal to 0. Okay. Let's apply what we just learned. So I'm going to split this down the middle. On the left-hand side, we're taking out GCF. So 2x squared. What's left behind? X minus 5. Check ourselves. 2 times negative 5 is negative 10. Yeah, so we good. Right-hand side, I know x minus 5 needs to show up. And then, so this is positive, so I'm factoring out a positive number. And it's going to be 32. Okay, so let's see what's happening. Something's happening. Oh, I know what's happening. No, I don't know. I don't know what's happening at all. So, feel like we went wrong. Just hate it when this happens. It's always so close to the end. Okay, let's see. Let's check our work. 2x, x minus 1, x plus 4. 2x, x minus 1, x plus 4. X times x is x squared. Negative 4x, negative x. Positive. Oh, I see it. Daggum. It's negative positive 4. It's positive 4. Which means this is not 32. It's going to be 8. And that makes more sense. So this is going to be 8. And then minus 40. Okay. That looks better because if I take out an 8, everything's kosher, right? So it's going to be 8 times x, 8x. 8 times negative 5, negative 40. So, putting it all together, we have x minus 5. Then the leftover pieces, 2x squared plus 8 is equal to 0. Okay, so 2x squared plus 8 equals 0. So if I subtract 8, divide both sides by 2, x squared is equal to negative 4. When I take a square root, we have a complex number. So we don't care about this one. Right-hand side, x minus 5 equals 0. We see that x is equal to 5. So let's check our answer because crazier things are happening. So 2 times 5 is going to be 10. 5 minus 1 is 4. And 5 minus 4 is 1. So 10 times 4 times 1 is 40. Okay. All right, number 30. We have the volume. And we have a cone. So the volume is 125 pi. It's kind of scary. And 4x minus 10. Some sort of base, it looks like. Or the diameter of the circle of the cone. And 3x is the height. Okay. So we need to figure out volume of a cone. So volume is going to be equal pi r squared, which is the radius, height divided by 3. Okay, so 3x is the height. The radius is going to be half the diameter. So 2x minus 5, right? If we divide everything by 2, this would be 2x minus 5. Okay, let's put it all together. So volume 125 pi is equal to what's it equal to? Pi r squared, so the radius is going to be 2x minus 5 squared, and then h, which is 3x, divided by 3. Okay. All right. Start simplifying some things. First thing I see is that the 3's can cancel. The next thing is that there's a pi on both sides. So if I start dividing by pi, both sides, right? I can do anything I want as long as I do it to both sides. So I'm dividing by pi. That's nice. Okay. 125 is equal to, right, there's an x here. We can't let that x get lost. 2x minus 5 squared. Okay, we can't distribute the x just yet because we have to expand the binomial because it's locked in the square. So this is going to be, so, right, my little trick. So I got x times, so 4x squared, positive 25, and then 2 times a times b, right? 2 times this times this. It's going to be negative 10 times 2, negative 20x. Okay. Running the x through everything. This is going to be, don't want to lose too much room here. So this is going to be 125 4x cubed minus 20x squared plus 25x. Now I want to subtract 125 from both sides. So minus 125. Right. On the left, we have 0. This is nice. It's nice. Okay. I'm going to split this down the middle. And on the left-hand side, GCF. 4x squared x minus 5. Right, 4x squared x cubed negative 20. All right, we good. Right-hand side, I know x minus 5 needs to show up. This homework really likes x minus 5 for some reason. So x minus 5. And then, so let's see if we can make that happen. So it's plus, if I take out a 25, does that make sense? 25 times x, 25x. 25 times negative 25 is negative 125. So this means, so it's all equal to 0. So x minus 5 times the outside parts, 4x squared plus 25. And this is all equal to 0. So I can already tell you this one's going to be a complex number. Can you see it? Right? You're subtracting 25 from both sides. You're taking the square root of a negative number. It ain't going to work. So left-hand side, x minus 5 is equal to 0. X is equal to 5. Scared to check my work because what if it doesn't work out? It should work out. So if we plug in 5, right, this is going to be 15. And this is going to be 10 minus 5, which is 10. So then we do pi, radius squared. So 10 squared, 100, times 15 divided by 3. So the radius is going to be 2 times 5, which is 10. 10 minus 5. 10 minus 5 is 5. 10 minus 5 is 5. So 5 squared is going to be 25. That makes more sense because now 15 and 3, that makes 5. 5 times 25 is 125, and thus we get 125 pi. Okay, factor completely by any method, by any means. Okay, what am I thinking? So I'm thinking that 27 is really 3 cubed. Thinking that y to the 6th is really y squared cubed, and then x cubed. So I can put the x in with the y. Right, because if you check our work, when we apply the cube, x cubed, y squared cubed, you multiply the exponents. So y to the 6th. All right, we good. So this is my a, this is my b. So xy squared is a, 3 is b. And this is a difference, right, a difference of cubes. So this is going to be a, which is xy squared, minus b, which is 3. So the pattern is minus plus plus. That's what I'm doing. So then a squared, so x squared, y to the 4th, plus a times b. So 3xy squared plus 9. Okay, I'm gonna leave it at that. Okay, we got our last problem. Okay. All right, I'm gonna treat this like a quadratic, only because. So remember in the other situations when x to the 4th, 2x squared, right? This term must be half of the leading, or this exponent is half of the leading exponent, and then you can treat it like a quadratic. Is that true? 2n divided by 2 is just n. So we're just going to treat this like a quadratic. So 2 numbers that multiply to make 1 that add up to 2. 1 and 1, right? Negative 1 and negative 1. So this means so negative 1, negative 1, right? Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is 2. Negative 2. Okay, our variable is just x to the n. X to the n. And that makes sense because if we distribute this, FOIL this out, we're going to get x times x. Common bases, you add the exponent. So n plus n is 2n. Okay. Okay, that's it. I like it. All right.